Yo, yo, yo. This is Mr. G talking about rotations in this video. So we're going to look at rotations as our third type of transformation. You've so far learned about translations and reflections. So now we're going to get to rotations. So rotations are a transformation in which we turn around a point. So now we have slid it. We have done a slide, which is a translation. We have done a flip, which is a reflection. Now we're doing a turn, which is a rotation. And we turn it around the center of rotation. Most of the time, our center of rotation is going to be the origin. Okay, most of the time it's going to be the origin. And that's all we're going to focus on right now. So I went ahead. Now, so let's look at it. I'm going to give you guys some tricks. We'll show how to do it algebraically, and then we'll move forward. So rotation 90 degree counterclockwise about the origin. So if I'm looking at this first image right here, 90 degrees counterclockwise about the origin. So first, counterclockwise, 90 degrees, which means I'm going to rotate it this way. So because this entire pre-image is in this first quadrant, that means the entire image is going to be located in the second quadrant. Okay. So what we can do, there's a few ways to do this. But one, I don't mind. One thing I like to do is I actually like to rotate if I have a piece of paper in front of me, I can rotate it around like that. And that gives me a visual of where it's going to be. I just did a 90-degree rotation counterclockwise. So I can see where my new points are at. Okay, so this is my new point B is over here at negative 1, 2, 3, 4, 5, 1, 2, 3, 4. This, I believe, is an S, is now a negative 1, 2, 1, 2. And then this is at 0, 1, 2, 3, 4, 5. So I can write down my new points right now. I can write those down off to the side if I wanted to. So I could say, hey, my new B, and I figured that out. That was at what? Negative 1, 2, 3, 4, 5, 1, 2, 3, 4. There's my new ordered pair. My new S, we said was at negative 2, 2. And then this new, what is that, an L? It's like an L. Is at 0, 5. Those are all the new points. I actually physically did the rotation. And I wrote down my new points. And I can just rotate it back. Okay. Rotate it back, move to here. And I'm done. Now I can actually plot those points. So again, B was at negative 5, 1, 2, 3, 4. S, 1, 2, 1, 2. And then 0, 5. And there is my new image. That is one way to do this. That is, of course, not the only way, but that works when we have it in front of you. Now, you guys aren't always going to have it in front of you, especially because of the simple fact that we are using computers a lot. Yes, you can actually physically rotate your screen, or some of you are even savvy enough where you can rotate your screen on your keyboard. And if you can do that, do it, and that gives you a visual. But another way we can do it is let's look at what our original points were, and let's look at what our new points were. Like, let's look at this B, for example. The B was originally 1, 2, 3, 4, 1, 2, 3, 4, 5. So it was originally 4, 5. Well, when we went 90 degrees, if we notice, it looks like the X and the Y swapped. So that's going to happen all the time. No matter if you go 90 degrees counterclockwise or if you go 90 degrees clockwise, your X and your Y are always going to swap places. Every single time, no matter what. So, if my X and my Y are always going to swap places when I go 90 degrees, that makes it pretty easy to know what the new points are. The only difference is then you just have to look at what quadrant you're going to end up in, and it's going to tell you what's going to be negative and what's going to be positive. So here's what I mean by that. In this particular quadrant here, in the top left, every single X value up here is negative, every Y value is positive. So I knew right away that this whole image was going to be all in here. So because of that, I knew that if I swap these, here's my original point. When I swap these, I shouldn't have the apostrophe there, sorry. My bad. Here, let me erase that. When I swapped them, I know that my X has to be negative, my Y has to be positive, just because that's where everything looks like in this quadrant. So, negative 5, 4. And that's how I got my new points. So let's look at what I just talked about, but let's look at it with this third one down here. I want to skip this one for now. We'll come back to it. But let's look at this one right here. So this one right here has us going 90 degrees clockwise about the origin. So 90 degrees clockwise. So if I were to take each one of these points that goes 90 degrees clockwise, 90 degrees clockwise, the clock rotates like this. So that means we're taking this C and we're rotating it 90 degrees to end up here. And it's already plotted for me. But so what happens is because this C was originally at 1, 2, 1, 2, 3, it's at 2, 3. Because I'm going 90 degrees, I'm going to swap them. So now it's going to become 3, 2. But then I got to look at just what are all the values in this quadrant. Well, all my x's are positive, my y's are negative. So x's are positive, y's are negative. So my new points will be negative 2. 1, 2, 3, 1, 2. There's my new C. This B, if I go 90 degrees clockwise, it's going to end up, I'll do this one in a different color, in quadrant 1. Zoinks, like that. Well, here everything's positive. So, for B, I just need to know I'm at negative 2, positive 3. So B was originally at negative 2, positive 3. So now I'm just going to swap them. So it's at 3, 2. And I know they're both positive. So positive 3, positive 2. 1, 2, 3, 1, 2. So that's how we use it like that. All you're doing is you're just figuring out what quadrant is it going to end up with. And if it's 90 degrees, just swap your x and y. Now with 180, 180 is a little bit different. 180, we actually don't swap our x and y. So it makes it a little bit easier. With 180, all we're doing is we're just changing the sign of our points. So here's what I mean. This h right here, it's wanting me to go 180 degrees. 180 degrees means to go to the quadrant diagonal from it. So this point is at negative 1, 2, 3, and it's at 1, 2, 3, 4, 5. Negative 3, negative 5. Oh, so that means if I swap it 180, go 180 degrees, it's now going to be at 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. There's my new h. And that's it. So this point right here is 0, negative 1. So now it's going to be at 0, 1. There's that, I think that's an O. There's my new O. This point doesn't have a name, but it's at negative 5, negative 3. So when I rotate 180 degrees, it's going to be at 5, 3. There's my new triangle that has been rotated 180 degrees about the origin. All right. That's really it. So let's do 2 more examples. We got one 90 degrees clockwise, and the other one's 90 degrees clockwise. So maybe try this one right here. Because we already did this one. I'm sorry. I don't know why we have this. We already did this. So do this one over here. Let me move this. Bam, make it like that. Let's make it nice and big. There we go. So I want you to work on this one. So pause it on your own. Try it on your own. And see how you do. So because we're going 90 degrees clockwise, just by looking at these points, here's what I know. Here's the nice part. I know that these are going to automatically switch. So that's going to be 2, 1. I know W prime is going to be 2, 0. I know K is going to be 2, 3. And then I know G, the new G is going to be 3, 3. Now I just have to figure out, okay, well, what quadrant are we going to? If I go 90 degrees clockwise. So when I started at 1, negative 2, this one, it is definitely nice to, here's my U. It's definitely nice to have a graph in front of you, I'm not going to lie, on rotations, because they are a little bit more visually, there's a little bit more, it's more easier, it's more visually appealing to be able to see what you're doing. And then G is at 3, negative 3. So here's all my points. Okay. So I already know what all my new values are. Now I just got to see which quadrant we're going to end up in. If we go clockwise, we're going this way. So let's see, U and G are both going to end up over here. Over here, everything's negative. So U and G, everything's going to be negative. So that makes that easy. W and K, let's see, if we go 90 degrees, they're going to end up right over here. So W, looks like we're still positive, so that's going to be good. And then K, this is the positive, negative quadrant, so positive, negative. Okay, let's actually write down these rules, though, for our algebraic rules, and this might even help you guys even more to know, so you don't even have to graph it. And we'll put this in our things to remember. 90 degrees clockwise. Okay, here it is. So we're taking our points. No, we're swapping them because we're going 90 degrees. But whenever we go 90 degrees clockwise, we're changing the value of the original y. So when I write a negative sign in front of it, that means I'm changing the value. It doesn't mean it's necessarily negative. And this is my original y. So this does not mean it's automatically going to be a negative x. So an example of this would be, let's say my original point was -2, 4. And I did a 90 degrees clockwise. Well, then what I'm doing is I'm making this I'm changing the value of my original y to negative, and I'm keeping my original x. So the new point would be I swapped them around, and I changed the sign of my original y. That would be an example of 90 degrees clockwise. 90 degrees counterclockwise. And some of you might be able to guess what this is. It's going to be very similar. We switch our x and y, but now our original x is going to change its value. And one thing I just realized, guys, I mixed these up. I messed up. This is actually clockwise. It's okay. I make mistakes. And this one's actually counter. My bad. Whew. Okay, let's change the title. There you go. So then an example of this one would be if I had the point, again, -2, 4. And I had to go 90 degrees clockwise for real, but I'm switching the sign of the original x. So my original x was, I'm swapping my x and y. So it's still going to be 4, 2, like 4. But then I'm changing the sign of the original x. So this is now going to become positive. Finally, 180 degrees. This one's the easier one, is we just change the signs of both. Okay, that's it. I hope I didn't confuse you. This 90 degrees counterclockwise. This is your algebraic representation. 90 degrees clockwise. This is your algebraic representation. I hope I didn't throw that off. And these are just examples of that. This is an example of it. This is an example of it. Okay, guys. Try the independent practice. See how you do. Let me know if you have any questions. That's it. Gradius out.